Welcome to tutorial number 3 for the VMT. This is a tutorial designed to take you through the process of creating a ReachWisePlot of depth or layer average velocities using preprocessed transects from VMT. So we're going to load files back into VMT that have already been processed and visualize the flow through a reach. All right, to get started, the first thing we have to do is go through loading our data files, and this tutorial assumes that you've gone through tutorial number 2 on the White Wabash confluence and generated cross-sectional average velocity distribution for the single transect. Well, what we've done here is done something similar for the Wabash-Imbra confluence, and we've done it at a number of different cross-sections, and we're now going to load those cross-sections back into VMT. Users don't have access to this particular data set, so you'll just have to follow along or follow along with your own data sets. But the process is very similar. So the first thing we have to do is select this MATLAB data files data import option. We're going to use those .mat files that were saved when we first processed the ASCII output data. And for the first run through, I'm going to turn off the cross-section contour plot because we're going to worry in this tutorial about a plan view plot or plan form plot through the reach. And so we're not going to be looking at our cross-sectional data. And everything else I'm going to leave set to the default settings. So I'm going to say load data. I'm going to navigate to our data files. And again, this is the Wabash Imbra confluence that we're going to be visualizing. So I go to our VMT process files directory that's within our data directory, and I say OK. And I want to load all the MAT files that correspond to the cross sections that I'm interested in. In this case, I want to load all the transects from or cross sections 005 to 008 all the way up to 41 to 44. So I'm going to leave off a couple on either end of this survey reach just to make it a little more concise and say OK. And once I've selected those, what the program's going to do is it's going to load each one of those MAT files and generate a depth average vector plot for me in plan view. So it's plotted here on my other screen. I'll move it in from the left here. And what we can see is we've got a series of cross sections through the reach, and we have our tributary coming in here. This is the Wabash River, this is the Imbra River, and we're visualizing the confluence of the two. So each one of these is a set of at least 4 transects that were collected and averaged in VMT and saved and reloaded in. They're all relative to the same color contour scale or color scale, that is, and the vector links also represent the magnitude. So in this case, we're looking at depth average velocities over the full measured depth at each cross section. And we have the ability to change a number of things, as you've seen in previous plots. And as we change these scalings, it's going to apply that scaling for all the cross sections. So the first thing we want to do is clean up this plot a little bit. When I first look at it, I see that we can make our vectors a little bit longer. We can probably reduce the number of vectors to make things a little more visually pleasing. So the first thing I'm going to do is increase the length of the vector. So I'm going to bump that up to 1.5 for the vector scale. And the vector spacing, I think instead of plotting a vector at every grid node, I'm going to plot every 4 grid nodes. And I'm going to go ahead and leave our smoothing window set to 1. So we're going to average with the grid node on either side of our data point. And once I have that set, I can say replot. And replotting is complete. We see that we now have a little bit clearer vector plot of our reach. Again, it doesn't make a whole lot of sense without some of the background imagery. So we can go in and add background imagery that I've downloaded ahead of time. So I'm going to say add background, and we'll go to our DOQQs here. This is a digital ortho quad that I downloaded from the USGS website. They're in UTM coordinates and GeoTIFF, so they work out nicely for this purpose. So I'm going to select that digital ortho quad and say open. And I just have the single file, so no, I don't want to add another. And so there we go. We've got a little bit clearer view of what's going on here. We've got the Imbra River coming into the Wabash River. We see a nice shear layer that's formed along the right bank. And so from here we have a couple of different options that I'd like to show you. So far we've plotted depth average velocities over the full measured depth of flow, and again that's the depth of flow that we're able to measure with an ADCP. It does not include the side lobe interference near the bed or the blanking distance near the surface. So what I'd like to show you here is the ability to do layer averaging within VMT, and so we've got a couple of options here. We can do we can input two values here, and it'll take the layer average between those two values. So for the first run through, let's go between 0 and 2 meters depth, and right now we're seeing between about 20 and just over 140 for our depth average velocities through the reach. We'd expect that if we average just the top of the water column, we'd see this increase a little bit as the highest flow tends to be near the surface. So we're going to go 0 to 2 meters depth and say replot. Say OK, and I'm going to go ahead and add that background again quickly. So we have it back to where we were before. So now we have a plot that's depth average over velocities over depths 0 to 2 meters, and we see we've gone up about just over 20 centimeters per second in our maximum velocities that were observed. We see a little bit more deviation of the flow near this confluence, but overall not a whole lot different than the depth average velocities over the full measure depth. We do have the ability to look deeper in the water column. Why don't we say between 8 and 12 meters depth? The bed is just under 12 meters, so we can put something that's a little bit deeper than the deepest point in the reach, and it'll give us basically this value all the way to the bed. And say replot. So here we have our depth average velocities, average over depths 8 to 12 meters, and we're only getting a vector plotted where there is valid velocity data within that 8 to 12 meter range. To make this a little more understandable, one thing we can do is overlay a background image, and rather than just overlaying the digital ortho quad that I've already shown you as it was downloaded from the USGS website, I can go a little bit further beyond that, and I've already gone through and exported the individual beam depth data using this output multi-beam bathymetry option within VMT, and I imported that into ArcGIS and created a bathymetric contour plot of this reach using the ADCP data. And I've overlaid that on top of the aerial photo and then gone and exported it as a GeoTIFF, which I can now bring back into VMT and have my aerial photo with overlaid bathymetry as a background option. So I can say add background, and it's taken me to where my files are already, and I select this GeoTIFF that I've created with the ADCP bathymetry, and I say open. No, I don't want to add another background file, and replotting complete. And so what we see now makes a little more sense. We have this scour hole that's out in front of the confluence. This is the deepest part of the cross section. Again, valid velocity data between 8 and 12 meters, where we have our velocity vectors. The little dots that you see on the screen here at each of the cross sections, those are grid node points that don't have any valid velocity data within that depth range. But it shows nicely that this bathymetry that we get from the ADCP matches up with our velocity data and correlates nicely as we see that the velocity vectors have aligned themselves within this scour trough here. They've aligned themselves with the bathymetry, and so we get that flow form interaction visualized nicely through this process. So that's the basic idea behind creating a ReachWise plot of depth or layer average velocity with VMT. You can do a lot more with it rather than having, say, bathymetry here. We could extract the temperature data using the ASCII to GIS tool and look at the temperature distribution along this cross section or along this reach and overlay our velocity vectors on top of that to have both the vectors and the temperature data visualize the shear layer and mixing zone between the two quite nicely. So there's a lot of different options. I encourage you to explore those using VMT and its utilities. And if you have any questions, please consult the user guide. Contact myself, Ryan Jackson, with USGS, or Dan Parsons with University of Leeds. Thank you.